Everyone, welcome to the first tutorial video of multivariate analysis class. I am Ryan. In this tutorial, I will talk about some coding techniques which are required in this class, and the content of this tutorial will not be included in the textbook, so don't forget to check out the related R Markdown file or HTML file on NTU Cool. In the first part of the tutorial video, I will talk about Tidyverse, and I will make a comparison between the Tidyverse style R and the base R. And if you are already familiar with base R style, and actually you can just skip this video. But I have to tell you this first. In the future tutorial videos and materials, I write my code in Tidyverse style. So if you are a base R user, you need to check the codes on the textbook. But if you are new to R, I think it's very worthy to learn about Tidyverse. And it will be a lot easier, at least for me, to complete the data manipulation or data cleaning or plotting using Tidyverse instead of like base R. Since we don't have that much time, I can only talk about the most frequently used Tidyverse syntax in this tutorial. If you want to become a master, you can look at the data camp classes. However, this is not free, so decide on your own. And I also find out some very useful reference both in English and Chinese here. And if you have any problem or you want to learn Tidyverse in a more structured way, and you can check out these documents. The first thing I'm going to introduce is the pipeline operator, and if you have seen some R code written in Tidyverse style, you may notice this weird symbol, the percentage larger than percentage, and this is the pipeline operator. And the pipeline operator will put objects usually on its left, and it's usually in data, like either in a data frame, a vector, or a matrix, and to the function on its right. So let's use the iris data as an example. And let's say if we want to take the mean of the sample length, and in previous, in our base R code, we just use mean and iris sample length, and we'll get the result. It's 5.84. But with the pipeline operator, we can do it like this. We choose the sample length from iris first, and then use the pipeline operator and use mean. So the pipeline operator will plug the iris sample length into the mean function, and we will get exactly the same result. You may wonder, well, how if the function has multiple parameters to input, can we still use the pipeline operator? The answer certainly is yes. So, for example, in the LM function, we need to put the y, the x, and the data in the function. So if we use the pipeline operator instead, still we can our data iris on the left of the pipeline operator and on the right is still the same function. The only different thing is that now we can use the dot to represent the iris data. So by doing this, we can still do the LM function using pipeline operator. You may wonder, well, I can do this exactly the same thing using base R. Why do I need to use pipeline operator? So it's very common when we are doing like data manipulation. We have to do multiple calculation on a data set. So for example, we may want to calculate the mean and variance of different species in the iris data set. And in this case, we need to do the following steps. So first, we need to select the columns we want, and we need to group the data by the species of different iris, and then we need to calculate the mean and variance. So how can we do this efficiently? So here is the code for doing that. So iris, the data, we have the iris and select the columns we want. Just use select. It's also a Tidyverse function. Just select the column name, and then we just group by, so species, and then we use the summarize functions to calculate the mean and variance. And by using the pipeline operator, we can do this calculation with a very clear logic. And if we want to do the same thing using base R and in one line, the code will be like this. So I will need some aggregate, and buy and fun. I just don't get this. I mean, maybe it's because I'm not as smart as others, but I think Tidyverse is more friendly. And we can check if the results are the same. Okay, yes, the mean of the sample length 5.0, 5.9, 6.5, exactly the same as the result from base R. So yeah, I think you can tell the advantage. And then in the second part, I want to teach you how to do some like very common tasks using Tidyverse. So I will tell you through all things. The first is column selection. The second one is row selection. The third one is I create a data frame, or it can be a table, a special data frame in Tidyverse package. And the last thing is how to add a column. So let's start from column selection. Actually, in the previous section, we have used that. It's just the select function. We can select anything we want, and the RStudio will suggest us the column name in the iris dataset. Oh, by the way, the short key to type the pipeline operator is Command Shift and M, or Control Shift and M in Windows. Let's go back to the selection. Okay, so we also have sample width. So we can do something like this. So, and also we can do the inverse selection, which means we can tell R which column we don't want. So just add a negative sign in the column before the column we don't want. For example, if we don't want the sample length column, we can do a select negative sample length. And yeah, here we go. We have all the columns except the sample length in the iris dataset. The second thing is about row selection, or we can call it filtering. And the according Tidyverse function is filter. So for example, if we want all the rows with a sample width larger than 3, we can just type this. Yeah, so easy. We get all the rows with sample length larger than 3, sample width. Let's say if we want to do like multiple filtering, I mean filter with multiple criteria, we and or operator. So for example, we want sample length also larger than 3, so we can just type sample length larger than 3. Yeah, so easy enough. It's creating a data frame or a table, and basically they are interchangeable and kind of the same. So it's very simple. On the we just type data dot frame, and the first row will be the first row is the first column in the data frame, and on the left side is the column name, and on the right side is the data. So this will result in a data frame looking like this. And then for table, it's basically the same. We just need to change the data frame to table. And yeah, it's just the same thing. And we can convert a data frame to a table, or a table to a data frame by using the as the data dot frame function. So let's convert a table to data frame. Yeah, still the same thing, and convert a data frame to table. Yeah, so they are just interchangeably. For the last thing, we are going to learn about how to add a new column for an existing data frame or table. So, for example, we want to add one column called length with ratio. So we want to add a new column to our original data 1, and it will equal to the length divided by width. We can use this, the dollar sign, which is the same as what we use for a column selection to do this. So our data line has one more column called ratio, and it's calculated from A divided by B. Also, there's another function called mutate we use here in data frame. So we need to assign a name first, so to call it ratio 2, and equal to A divided by B. So for now, data one will look like this. Yeah, it's the same, ratio 2. So what's the difference between using the dollar sign and using mutate? So it's again, mutate is usually used with the pipeline operator. So we can, with the pipeline operator, we can chain a lot of operations together and write a better R code. So for example, if we want a data frame with column A representing sample length, column B representing sample width, and the third column representing the ratio of A divided by B, we can use pipeline operator with mutate and write the code in one line. It will be like this. We can construct a data frame of A and B first, and then chain mutate using the pipeline operator and then to calculate the ratio here, and we will get exactly that result.